Okay, welcome to the final exam review for intermediate algebra, MAT1033C. So if you're in here, then obviously you know how to navigate this course, but just to show you where everything is again, this is being recorded and will be posted under intermediate algebra. Click on that. We are over here in test review material. So this recording, so this is IMath.AS. So if you want to look at some past IMath.AS exam reviews, we've got some right there with a blank review, the solution guide, and a video. If you are doing My Math Lab, then here is the blank review that we're going to be working off of. I'm going to be showing the My Math Lab version this time. So here's the blank review. Feel free to download it. The solution guide we're working on right now, the recording we are doing right now, and that will be placed right here. So there you go. So those of you that are in IMath.AS, you've got these versions right here that you can look at, and both of them are different. And then those of you in My Math Lab, we're going to be doing that one right now. And we have the blank document, the solution guide we're working on right now. And we are also recording this video. And I think I just got kicked. Sorry about that. Had a little technical difficulty. Was just trying to hide my little floating keys here. So again, back where we were, intermediate algebra, test review materials. I talked about the IMath.AS, and then if you click on the My Math Lab, again, this is the ones that we're doing right now. Here's the blank. There's the solution guide that we're going to be working on right now, and the video. And away we go. So I don't need that anymore. So that way my computer won't slow down. Okay. So here we go. So question number one, a compound inequality. And is this going to be an and or an or? What do we got here? What do you all think? Is this an and compound or an or?
Or.
And
All right. So I had a couple different this guy right here, number one, it's going to be an and. It says and right there in the middle. So this is an and. Where do ands normally shade? So here's our problem. Where do ands normally like to shade?
Where they overlap.
Where they overlap, absolutely. Which usually happens in the middle. So like if we had a number line, ands usually like to shade in there. But definitely correct. And is all about where they overlap or what they have in common when we shade. So let's take these two problems and let's solve them individually. Okay. So how do I get x by itself right here with the negative 3x less than negative 12?
Divide both sides by -3.
Yay. Divide by -3, divide by -3, x negative 12 divided by 9 stay less than, or does it flip and become a greater than?
It flips.
It does flip. So it actually becomes x greater than 4. And again, whenever you divide, if this bottom number right there is negative, that's what caused the flipping. We don't care if the numerator is negative. We care if that denominator is negative. Okay. So because this guy's negative, that's why we flipped. All right. How do we solve the x minus 4 less than 6?
Add 4 to 6.
You got it. So plus 4 plus 4. X is less than 10. Good. So now if we draw these real quick, I make my number lines really simple. I just worry about the two numbers. So we have a 4, that's our smallest, and then we have the 10. So if we graph this above here, will this be a bracket or parenthesis at 4?
Parentheses.
A parenthesis.
I think it would be a bracket.
Well, it's not a bracket at 4 because it's not equal to. Brackets have to have the line underneath it. So because there's no line here, it's actual parenthesis.
Okay.
No worries. So it's definitely a parenthesis, but does it shade to the left or will it shade to the right?
To the right?
To the right. Follow the arrow. It's pointing to the right. So that one looks like this, and I put it above my line. All right, let's do the x less than 10. Bracket or parenthesis at 10.
Parentheses.
A parenthesis, will it shade to the right or to the left? Which direction?
To the right?
Which way is the arrow pointing?
Oh, it's to the left.
To the left. So it looks like this. So where is the overlap gonna happen? Because you said ands are all about overlap.
Between 4 and 10.
Between 4 and 10, just like what I kind of talked about up here.
Is
Most
the
of the
overlap.
time. Yeah. So it's going to be a parenthesis, and shade between. So this is what the picture looks like. Now let's talk about our answers, because our answers can be in one of two forms. They can be in set, or they can be in interval. Okay. So let's go and let's look. So the one that they want us to do in my math lab is interval notation. I think in iMath.AS, you might be looking at set, if I remember correctly. So let's take a look at both. So set notation starts out with our squiggle. That's what I call it, but it's really called a brace. X and a line. Now, what does this look like as my answer for the set? So how do we write up this set and answer? What are we gonna keep going?
Would it be Forgot the name of the. I think it's a bracket, but it has the
Well, when we do sets, there's no brackets or parentheses. That's interval.
Okay. Oh, wait a minute.
I call this answer my pinball answer because the first thing you're gonna start with is your lowest number, 4. Your highest number goes on the other end. Okay? Between these is your X because X is stuck between these two numbers. See how we're shading in here? This is like pinball. You're bouncing back and forth. Ding, 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 ding. You can't get outside 4 and 10. So your X is stuck between these two. You follow me so far?
Yeah.
Then all you have to do in here is either put a less than
Yes.
or a less than or equal sign. So the set answers generally look like this. It's your small number first. Then it's less than or equal to, X, less than or equal to your other number, which is the large one. That's how the general set answer looks. So you can see that I've got my small number. I've got my large number, small, large. My X is in the middle. Now the question is this a less than or is this a less than or equal to?
A less than.
Yeah, they're both going to be less thans because they're both parentheses. And if you look right here, see, it's a less than, or well, there's no equal tos. That's how you know. And these are always less thans. So this right here is the set answer. Let's talk the interval. The interval is just what you see right up here. So where does the interval begin? At what number?
4.
4. Is it a bracket or a parenthesis at 4?
Parentheses.
It was a parenthesis. Comma. Where does it end?
10.
At 10. Bracket or parenthesis?
Parenthesis.
With a parenthesis.
And there you go. There's your interval answer. So that's how this problem works. So if you're kind of looking at the interval answer for this, it's either a bracket, parenthesis, and then it's your small number, comma, your large number, and then it's a bracket or a parenthesis. So most of the time, this is what ands are doing, most of the time. But there is the occasional where it will shoot off in one direction. Just so you know. Any questions about number 1?
No.
No.
Perfect. All right, let's talk about number 2. Number 2 is another compound inequality. So is this one an and or an or?
Or.
This one is an
An
or.
or.
And we know that because it says or. All right. So I've got it down. Where do ors usually shade?
Everywhere else. To one side.
Usually everywhere else. So if it's not the inside, like ands usually shade the inside, ors generally shade the outside. So in general, ors tend to look like this when we graph them. We shade the arrows. to the outsides. Like that. Ors tend to shade the outside. Because generally what ors want is all the shading. It's generally how I think about ors. Wherever there's shading, it's coming to the party. All right, so let's do some solving. So how do I solve negative 5x less than or equal to 20?
Divided by
Divided by -5.
Yeah, you both got it. Divide by that negative 5. Divide by that negative 5. We get x 20 divided by -5, -4. Does it stay less than or equal to, or does it become greater than or equal to?
it's
Greater than to equal to.
Yeah, greater than or equal to. It flips because right here, that bottom number is negative again. All right, so let's solve this other one. 4x minus 22 greater than or equal to -2. How do I start to get this x by itself? What are we going to do?
plus 22 on both sides.
Boom goes the dynamite. 4x greater than or equal to, this gives us a positive 20. And then what?
Divided by 4.
Divide by 4. Divide by 4. X is greater than or equal to 20 divided by 4, 5. All right, so let's do a quick shade. Again, I keep my number line very simple. -4, 5. All right, so let's do this guy right here. X greater than or equal to -4. So bracket or parenthesis at -4.
Bracket. Bracket.
It's going to be a bracket. Okay, because it's equal to. Does it shade to the right or to the left?
To the right.
To the right. Follow that arrow. So there's what x greater than negative or greater than or equal to -4 looks like. All right, bracket or parenthesis at 5 because we're looking at x greater than or equal to 5.
Bracket.
Bracket, shade to the right or to the left?
To the right.
To the right. All right. So ors are all about wherever there is shading. So where does all my shading start? We don't care if it overlaps or not. We just want wherever there's shading. Where does it start?
It starts -4.
It does. And which direction does it go? Does it go to the right or does it go to the left?
To the right.
To the right. And that's what it looks like. Because we don't have to worry about this because it's already covered right here. So this is our graph. Notice it's a little different. So this OR is not shading to the outsides, it's just shading to one side, and that's okay. Normally ORs look like this, but sometimes we have those special cases. So let's talk about set. And let's talk about interval. Okay. So set. Again, it always starts out with your little squiggles, your X and a line, and it's going to end with your squiggles. So this one is not like our and answer where it was a pinball answer. Okay. It's not like this one. This answer will start with X. And then you will either put in greater than or equal to, less than or equal to, greater than or less than, because of the way it's shaded. So are we going to put a greater than or equal to, a less than or equal to, a greater than, or a less than in for our symbol here? Which one of those symbols is it going to be?
Greater than or equal to.
It is going to be a greater than or equal to because it is a bracket and it shades to the right. Shading to the right is always a greater than sign. And it's a bracket because we're equal to. And then all you got to do is tell me where it started. Where did this shading start?
-4.
There's the set answer. Notice it was actually one of our answers that was up here. See, x greater than or equal to -4, x greater than or equal to -4. All right, the interval, just write down what you see right here. So where does my interval start?
-4.
Bracket or a parenthesis?
A bracket.
You got it. See, because it's a bracket here. It's just what you see. Where does it go?
Infinite.
To the right.
To infinity. That's right. This arrow, when you fill in an arrow, that's an infinity. And this is the positive one. Bracket or parenthesis on infinities?
Parentheses.
Parenthesis. Infinities always get parentheses. Good job. So here is what the picture looks like. Here is the set answer. And here is the interval answer. Just so you know, if this was an or answers as sets usually look like this. You've got x less than, or equal to your number, that is the small one, or x greater than, or equal to your other number, which is the large one. So what tends to happen is these are the two answers that get put in there. As an interval, it looks like this, generally. Parenthesis, negative infinity, comma, your small number, and it's either a bracket or parenthesis, union, bracket or parenthesis, your large number, comma, infinity, parenthesis. So this is what a normal or answer usually looks like. This is just one of our special ones that's not following the rules. Please know that this is a union symbol. This is not a capital U. So make sure in iMathAS or in My Math Lab that you actually use the union symbol that is provided by the program. Do not use a capital U. It will count it wrong. All right. Any questions about compound inequalities? Those two problems tend to trip people. Yeah, those two problems tend to trip up a lot of students. So just be careful. All right. So number 3, absolute value equations. So we got the absolute value of 4x minus 16 equal to the absolute value of 9x plus 10. How many answers do absolute values have?
I think it's 2.
You bet. There are 2. So that means there are 2 equations that you need to set up and solve. What I know as a math teacher, as a math professor, is that you guys are really good at solving for equation 1 and getting that answer, but it's equation 2 that generally messes you up. So let's talk through this. Make sure that you understand that those are absolute values. So what does equation number 1 look like? This is the one that most of you are all really good at doing. What does equation 1 look like that we have to solve?
4x minus 16.
4x minus 16 equals
0.
not 0.
Nine x plus 10.
There you go. Yeah. When you make your first equation, like I said, this is the one that you're all really good at. All you do is just drop those absolute values. So you got 4x minus 16 equal 9x plus 10. Equation number 1, all you do, drop the absolute values. Drop it like it's hot. Okay. And then now we can solve. So let's do that. Let's solve this one real quick. So how we get x by itself? What are we going to do?
Plus 16.
Okay. Plus 16 plus 16. 4x equals 9x, and 10 plus 16, 26. Now what?
Divided by 4.
No dividing yet.
No. Oh,
Got to get all your x's on one side.
Minus 4.
Minus 4.
4x.
We can do that, but let's move the 9. Because if I do that, I still then got to
Okay.
move everybody away again. So let's move this over there. So that'll give us negative 5x equal to 26. And now what?
divided by negative 5 on both sides.
You got it. So x is equal to, and then this is where you'll want to go to your calculator. Because I know in both my math lab and iMath AS, it will want fractions. Okay, no decimals. So if you go to your calculator, this is the TI-84, you can input fractions by hitting alpha y equals. And all you do is 26 over negative 5. Hit enter, and there it is, the reduced fraction. So let your calculator, if you don't know how to reduce fractions, do it for you. So our answer for x is negative 26 over 5. And that's a-okay. That's one of our answers. Okay, let's talk about the second equation. So we know this is good. How do I get the second equation? This is the one that messes things up. What do you think it looks like?
Wouldn't the second one become a negative on 9x?
Okay, so let's talk about that. So you want to keep the 4x minus 16 like that? And then you said that this should become negative, just the 9x?
I think so.
It's not just the 9x, but I like where you're going. Yes, you want to take the opposite of this side.
And negative 10.
And the 10 will become its opposite. So basically, when I talk about equation 2, you're going to drop the absolute values, but then you take the right side and you make them their opposites. So a positive 9x becomes a negative 9x. A positive 10 became a negative 10.
Okay.
If this was 9x minus 10, then I would have had negative 9x plus 10 here, if that was a minus. The entire right side becomes their opposite signs. So positives becomes negative, negatives become positive. So everybody's the opposites, and now all we do is solve. So how do we solve this? What are we going to do?
Plus 16 on both sides.
Okay. So 4x equals negative 9x. And then this time that will give us a positive 6. Now what?
Will be yeah, positive 9x
plus 9x.
Yeah, there you go. Let's get all of our x's all on one side. So add 9x. So that'll give us 13x equal to 6. And now what?
Divide by 13 on both sides.
Yeah, you guys are killing it. So x is equal to, and if you go to your calculator, this does not reduce. So it stays as 6/13, and those are the two answers. You'll just put a comma between them. Cool beans?
Yeah.
All right, let's move
You
on.
said put what between them?
A comma. Or,
Oh, okay.
well, in my math lab, you put a comma. See, it says put a comma. I think you might have two separate boxes. So just make sure you know which one is your smallest answer and which one is your largest answer. So this would be your smallest answer because it's the negative one. This is your largest because it's the positive one.
Yeah, okay.
Yeah.
Okay, thanks.
No worries. All right, number 4. Talk about it. Number 4 says, find the equation of the line passing through the 2 points. So we got 2 comma 7 and -6 comma 19. All right, so we want to find this equation. Well, what do we need to find first? And our equation must look like slope intercept, mx plus b.
Well, to find the slope first.
You got to find the slope first. Yeah, how do we find slope? What's the formula?
Y
Y, yes.
Why?
y2 minus y1
Okay, I like it.
divided by x2 minus x1.
Absolutely. And just so you know, it is a-okay to do y1 minus y2 all over x1 minus x2. Now, points are made up of x and y. I always like to label them so I know exactly who is who. This is x what and y what. Is that 1 or 2s? What do we got here?
So it'd be
It doesn't matter which one as which, right?
It doesn't really matter, but because of what I got here, since this is my first point, I would call these the ones. 1 standing for first point. Then these would be my 2s. But it really didn't matter which point was which. This could have been x1, y1. This could have been x2, y2. So let's fill in. What is our y2?
19.
Minus, what's our y1?
7.
Okay. What's our x2?
-6.
Minus, because of the formula. And what's our x1?
-2. Oh, -2.
Yeah. So you need both of these. This is from the formula right here. This one is because of my number. Both of them get written down. Formula, number. All right. So 19 minus 7 gives us 12. What happens with two negatives by each other?
It turns it into a positive.
So this becomes -6 plus.
Plus -4.
So -4. Good. So -6 plus 2, -4. And 12 divided by -4 is -3. So there's our slope. Your slope is always reduced. All right, so now that we know the slope, what are we going to do? We've got a slope. We need to write this equation.
You substituted for the m for the 2. I mean, for the slope.
Okay, so we want to put the -3 in here for the m. But then what else do we need?
We need the b, the y-intercept.
You got to figure out the y-intercept. And how are we going to do that? What should we use to help us out? We've got a slope, and we need one other piece of information to help us figure out the y-intercept. What other pieces of information do we need?
The x.
You need a point, because you can do this one of two ways. Some professors will teach you that you can plug right back into this. So I'm going to choose this as our point because it's smaller numbers. So all we got to do is take and plug in the point for x and y. And you know the slope is 3, -3. And then we can solve for b. So our y value is 7 equal to, our slope is -3. Our x value is -2 plus b. So now we can solve for b and then get our equation. What's -3 times -2?
+6.
Plus b. And then how do I get b by itself?
Subtract 6.
Yay. And b is equal to 1. And now you have everything you need. You've got the b, you've got the m. We can write our equation. So f of x equals -3 x plus 1. Now, let me show you another way to get this equation as well, too. Some professors, and I am one of them, like instead of doing this, we like to use what is called point slope. Y minus y1 equals m parentheses x minus x1 to write our equations. I like point slope because it tells you everything that you need. It tells you that you need the m and you need a point, which is why I chose this guy and this one. Notice, oh, x1, y1, m. Oh, there's all that information. So let's fill in. And the other reason why I like using point slope is because we're going to manipulate this into that. I don't have to rewrite my equation after I'm done solving. So y minus my y1 is 7 equals my m is -3 parentheses x minus, so the minus because of that, my x1 is -2. So again, you need both of these because this minus comes from the formula. This negative comes from the 2. Okay, so y minus 7 equals, we're going to distribute the 3 through the parenthesis. So what's -3 times x?
Positive 6. Oh, wait, no.
-3x, and then we're going to get to that. And then over here, we're going to have A negative by a negative, which is a positive. So what's -3 times a +2? It's a -3 times a +2.
-6.
And then how do I get this y by itself? All we got to do is
Plus 7.
which leads us right back to our answer right there. Because -6 plus 7 is 1. So two different ways to approach it. Either way, you got to find the slope first. Cool beans?
Yes.
All right, moving on. Number 5. So write the equation of a line with the following information. It goes through the point 7 comma -4 and is perpendicular to 6y equal to x minus 12. All right. Sorry, just writing some things down real quick. So let me talk you through how I do this. Usually with my students, what I do with this kind of problem, because this is one of the most missed problems in algebra. This really throws us off. I give them like a setup to this. So let me show you what my setup looks like. My setup looks like line 1, there's a relationship, and then there's a line 2. So there's a relationship between these two lines. Under line 1 goes the equation they give us. So if we come back, my equation they give us is right here. 6y equal to x minus 12. The relationship is either that it's parallel or it's perpendicular. So go back in here. Our relationship then is perpendicular. Under line 2 goes the point. So here's our point. 7, -4. And that's my setup. The rest of the information that's up there is junk. It's all fluff and stuff. So this is what it looks like. Your equation goes under line 1. There's a relationship. It's either parallel or perpendicular. Ours is perpendicular. The point goes under line 2. Our goal is to get the equation for line 2. That's what they want. So here's how we do this. For line 1, you're only after one thing. For line 1, all you need to do is find the slope. Can we find the slope for line 1 right now?
Yes.
No, because we don't have points.
Well, you don't need points to find the slope, but we're almost there. We can find the slope from this, but we got to do one thing first. We need to get y by itself. Because if we can get this into y equals mx plus b, we can find that slope. See, right now it says it's 6y equals. We just want y. So how do I get rid of the 6 in front of the y?
You would divide it.
You got it. We're going to divide. And what I tell my students is that each number is going to get divided. I don't come over here and put a giant line and say divided by 6. I don't do that. But each number gets divided by 6. So what you end up with is y equals, well, 1/6, that's going to stay because we don't want decimals. And then 12 divided by 6 is 2. Now we know what the slope of line 1 is. What's the slope?
1/6.
1/6.
1/6, the 1 over the 6. There we go. So there's step 1. That's the only thing that line 1 is good for. We just need the slope. All right. Step 2. Use the relationship to find the slope of line 2. So we're going to find the slope for line 2. So our slope is perpendicular. So what does that do to this? What is the perpendicular slope to 1/6?
-6.
-6. Good job. Because perpendicular slopes, you take the opposite reciprocal. Means change the sign and flip it. So the opposite of a positive number is negative. And when you flip this, you get 6 over 1, which is just 6. If it was parallel, they're the same. So if this was parallel slopes, if this was 1/6, this would have been 1/6, but they're not. They're perpendicular. So keep that in mind. So there's step 2. And now we're right back to what we just did in number 4. We have a point and we have a slope. Step 3 is write the equation. And I showed you 2 ways to do this. We can plug into y equals mx plus b, or you can use point slope, y1 or y minus y1 equals m parenthesis x minus x1. So all we got to do is plug in. And again, this is your x1, this is your y1. There's your m, there's your point. So what's our y value?
-4.
-4.
Equals, what's our m?
-6.
-6.
What's our x?
7.
Plus b. All right. So 6 times 7, or -6 times 7,
-42.
and all we got to do now is add the 42 to the other side. So b is equal to a positive 38. So our equation, f of x equals -6 x plus 38. You get the same answer if we do it through here. You'd have y minus, and it's a -4, so that's a -4 equals our m, which is -6, parenthesis x minus 7. So we'll distribute through. So -6x plus 42. Over here, that becomes y plus 4. And then just subtract 4. And now you're right back at the same answer. Any questions about number 5?
No.
It's a nice little 3-step process.
Okay.
Find the slope of line 1. That's all it's good for. Use the relationship to find your new slope. And then write your equation. Number 6. Okay. So we're going to find the domain. All right. All domains are always what in the beginning? We always assume all domains are what?
Positive.
A little bit more than that. We always assume domains are all what in the beginning?
All real numbers?
All real numbers. So from negative infinity to positive infinity. Unless we are two cases. What two functions throw off domains? What are they called? What two functions throw off domains? You've studied both of these. They're the last two functions you study before quadratics.
G of x and f of x.
Well, those are function. That's just
Is that
function
what you mean?
notation. This is called function notation. So g of x, f of x. But it's a special kind of function, like linear is a function. Polynomials is a function. Absolute values are functions. There are two functions that throw off the all reals.
Quadratic?
Not quadratic. They're both R words.
Rational?
Rational. This is a rational function because it looks like a fraction. What's the other one that throws it off?
Radical?
Radical.
There you go. Rationals and radicals throw off that domain. Okay. So because this is rational, we got to fix this. How do we find rational domains? What do we got to do?
Set the denominator equal to 0?
You bet. Take the denominator, set it equal to 0, because these are going to find the numbers we do not like. Okay. So we got 3x plus 7 equal to 0. All right, solve. What are we going to do?
Subtract 7?
Perfect. So 3x is equal to a negative 7. And then what?
Divide by 3.
Perfecto. Now, you know that the number we do not like is negative 7/3. We do not like this number. So we can write our domain two different ways. We can do set, or you can do interval. It's your call. Well, not your call, but it's your exam's call. Okay. So set notation is pretty easy. Get your little squiggles, your X with a line, and then pretty much inside here, you're going to write your equation, your answer part, and you're going to do one little thing. Put a line through the equal sign. There's set. So you just write out your answer and then put a line through the equal sign. There's what set notation looks like. Interval notation kind of looks like those OR answers we had at the beginning when we talked about compound inequalities. OR answers start at negative infinity, generally, and it's going to go up to our number, and then we're going to jump over it. Parenthesis, union, parenthesis. And then you're going to pick up on the other side of the number and go off to infinity. So these are the two kinds of answers. I think in iMathAS, you're putting in the interval. And in MyMathLab, you're just going to type in the number in the blank. So these are the answers that you're looking for. There's the domain to the rational. Any questions over number 6? Okay. Number 7. So number 7, we've got a couple different things. So this is where it's definitely different than iMathAS. So we want to find the domain to this. And it also wants us to fill in the table and to pick the graph. All right. So let me write down what I know. And then we'll talk about the domain. So we got f of x equals the square root of x minus 3. I've got this table, x and f of x. 3, 4, 7, and 12. And then they want us to graph. Okay. Five, 10, 11, 12. Sorry, I just have to redraw my graphs and everything. Okay. So let's talk domain. Again, from before, we always assume our domains are all reals, except when we're a rational or we are a radical. How do we find the domain of a radical? What are we going to do?
Remove the square root.
Say it again.
Remove the square root.
We're going to remove the square root. So we're going to take this polynomial and set it what?
Equal to 0.
Not equal to 0, but close.
It greater than?
Greater than or equal to 0. So all you do is take whatever's underneath the radical, set it greater than or equal to 0. So if we take x minus 3, set it greater than or equal to 0, all we got to do is add 3. X is greater than or equal to 3. So if we want to write the set is really easy for this. Set, you're looking at the answer right there. X, your squiggle, your X, your bar, just put X greater than or equal to 3. There's your set. Interval, super easy. If you made like a quick graph of this, it will look like this. It's a bracket and shades to the right. So if I made a quick graph of X greater than or equal to 3. So if I did interval, where does my shading start?
At 3.
At 3, bracket or parenthesis?
Bracket.
Bracket. And where does it go?
To positive infinity.
Is greater than
Positive infinity.
infinity.
And there's your interval. So there's the first part. We found the domain. Everything else is just going to verify this. So all they want you to do here is plug in. So they just want you to take 3 minus 3, which gives us the square root of 0. What's the square root of 0? Come on, what's the square root of 0?
0.
0. There's our first answer. Then all you're going to do is plug in again. This time, you're going to put a 4. 4 minus 3 is 1. What's the square root of 1?
One.
There's the second answer. Then we're going to take and we're going to plug in 7. 7 minus 3, which gives us the square root of 4. What's the square root of 4?
2.
2.
2.
Anybody want to take a guess as the last answer? Because 12 minus 3 is 9. Square root of 9 is
3.
3. So all you do is just plot these points. 3, 0, 4, 1, 7, 2, 12, 3. All right, so 3, 0, 4, 1, 7, so 5, 6, 7, 2, and 12 is up at 3. And there's the graph. So if I come out here, which picture is it? Is it A, B, C, or D?
D.
It is not D, because if you look at this, it starts right here at 0, 0. Our graph starts all the way out here. Say it again. You said it.
It'd be A.
It is A. Yeah. Because it does not grow very fast. This one, C kind of looks like it, but it's growing too fast. So look at how slow this graph is. Out at 12, I'm only up at number 3. So it's growing really, really slow. So there you go. Your graph is A. In the table, you got 0, 1, 2, 3. And then down here is your domains, depending on which one they ask, whether it's interval or set. I think for ours, they wanted interval. All right. Moving on. Moving on. Number 8. Number 8 says that there are 2 functions that can be used to describe the percentage of people 25 years or older who have completed at least high school. For both functions, so one of our functions is f of x equals 0.45x plus 87.3. And we got g of x, which is equal to 0.009 x squared plus 0.42x plus 87.3. So it says X is the number of years since 2008. So that's important to know. Years since 2008. And Y, or f of x or g of x, is the percent of people 25 or older completing at least high school. Assume that the trend continues for G, which is fine. It says find G of 12 and describe in words what it means. Okay. So here's what we know. What are they wanting us to do with this G of 12? What are we going to do here?
Plug in 12 for the x
For which one?
for g of x.
You got it. Take this 12 and we're going to put it right in here. This is the only equation we need to be worried about. So we're going to take 12. We're going to plug it in. And I'm going to go straight to my calculator and let it do its job. I'm not doing this by hand. That's just silly talk. So I'm going to go to my calculator. And I'm going to put this exactly the way you see it here in my calculator and let it kick out the answer for me. So calculator 0.0 or actually 0.009 parenthesis 12, close the parenthesis, raise it to the second power, plus 0.42 parenthesis 12, close it, plus 87.3. That is the same way I wrote it on my piece of paper. See? Looks the exact same. Just hit enter, and there's our answer. 93.636. So we now know the first answer. 93.636. Now it says describe in words. So remember, X represents the number of years since 2008. Y is the percent of people 25 and older completing at least high school. So the first thing it says in all of these, it says in the year blank. So it sounds like we need to figure out the year. So what year is it if your X value you told me was 12? What year are we really looking at?
2020.
2020. All right. So in one of these blanks, we're going to put 2020. Okay. All right. Now, remember that the Y value is all about the percent of people 25 and older completing at least high school. So A says less than blank percent of people 25 and older will have completed at least high school. Blank of all people will have completed at least high school. Or this percentage of people 25 and older will have completed at least high school. Which one is it? A, B, or C?
A.
Say it again.
A.
A. It is not A, because there's nothing up here that says that we are less than this percent. It says this is the percentage of people, not this is less than the percentage of people. Does that make sense?
Yes. So
So
is
it's
it
not
C?
A, it is C, because this matches the wording that we have up here. Percentage of people 25 and older completing at least high school. Percentage of people 25 and older will have completed at least high school. So it is C. So you'll select C and say in the year 2020, 93.636% of people 25 and older will have completed at least high school. All right, number 9. So elimination, substitution, we're getting into solving systems. That's what we're getting into here. So 9, 10, and 11, these are all systems. Now, I know number 9 says use elimination, but as I've told my students, you know 3 ways to solve systems. You know graphing, you know elimination, you know substitution. I don't care what method you use, and I'm sure your professor doesn't. Well, your professor might care, depending on who they are. But as long as you can get to that answer, it doesn't matter whether you use elimination, substitution, or graphing. You got to the answer, and that's all that's all that really matters, is that you know a way to do it. But I will let you know this one, since it says elimination, it probably is the easiest method to use, although you can do substitution for this, just so you guys know. So we got 5x plus 2y equal to 16 and x minus 3y equal to 10. So we're going to go ahead and solve this using elimination, since it says to use elimination. So I need your help. Let's go with Wesley. Wesley, pick a variable, and it doesn't matter which one. Pick one, X or Y.
X.
X. Let's go with X. It would have been easier to get rid of the Y's, but that's neither here nor there. We're going to go with X. So I need to make sure that both of these will have the same number in front, and one of them is positive and one of them is negative. Right now I have 5 and 1. So what can I do to make these the same number? What can I turn them into? I've got 5 and 1 right now. And this is for anybody now. I just had Wesley pick our variables. So what number can I turn them into?
5,
5. Absolutely. We'll make them both 5. And then which one should be the negative, the top one or the bottom one? Again, it doesn't matter.
bottom one,
The bottom one, that's fine. So we're going to make both these equations have a 5 for x, and we're going to make this bottom one a negative. So since this top one already matches, don't change it. So we're going to leave the top one alone. But this bottom one, I need to turn the 1 into the -5. So what will I multiply 1 by to become -5?
Negative 5.
-5. So this whole bottom equation here is going to get multiplied by -5. So -5 times 1 gives us the -5x, which we knew was going to happen. And -5 times -3y gives us a positive 15y. And -5 times 10 gives us a -50. And so now we're ready to do elimination. All we got to do is add down. So what's going to happen to the x's?
They,
cancel out.
Yeah, they cancel out. They eliminate. 2y, 15y, 17y, and 16 plus a -50 is -34. Now what are we going to do?
Divide by 17.
Boom goes the dynamite. And y will equal -2. So you now know that y is a -2. How do we find x?
Plug in Y.
Yeah, plug in y. And it doesn't matter which one. Let's go, Natalia. Do you want to plug into the top equation or the bottom equation? Which one would you want to plug into?
bottom.
Yeah, and I always go back to one of the beginning ones. I don't use what I had over here. I use one of my originals because I know that these are written correctly. So you said the bottom one, so let's plug into the bottom one. So we have x minus 3 times a -2 equal to 10. All right, so what's -3 and -2?
5. -5.
How about a positive 6 because you're multiplying?
Oh,
It's okay. And then how do I get x by itself? What are we going to do?
take away 6 from both sides.
So x is equal to 4. And now you know the answer. 4, comma 2. Sorry, 4, comma -2. Done. All right. So number 10. Number 10. Another system. Wrong thing. Number 10. So we've got x equal to 3y plus 2 and 4x minus 12y equals 8. So this one just says solve the system. So again, this one you really do have free choice. You can either solve it using elimination, or you can solve it using substitution, or you can solve it doing graphing. It's your call. Okay. So what's the easiest method to use on this one? What do you think?
Elimination.
Elimination. Elimination's okay.
Substitution.
Yeah. Substitution's better. Why? Why would I use substitution?
Oh, because it already tells us what X is.
Yeah, right here. We already know what X is. X is 3y plus 2. All we need to do is substitute it in. Yeah, so I would do substitution on this one. Notice one of your problems was elimination. One of them was substitution. Weird. All right. So all we got to do is plug in. So we're going to have 4 parenthesis 3y plus 2 minus 12y equal to 8. All I did was take the 3y plus 2 and plug it in for my x. This used to be x. And so let's solve. What are we going to do now? How do we solve this?
Distribute. The
Distribute.
4.
You got it. So that'll give us 12y plus 8 minus 12y equals 8. All right, now what?
Minus 8.
Subtract 8.
We can subtract 8, but we can do this even faster if we just put like terms together real quick. What's going to happen with 12y and negative 12y?
So
They're going to cancel out. So what we're left with is 8 equal to 8. No more variables. What does this mean? What
There's
happens?
Infinite solutions.
It's infinite, you bet, because these are the same. That means this is the infinite solution. Infinite solutions. So I think in iMath AS, you guys put infinity, comma, infinity. And in my math lab, you guys will select B. B is the infinite choice. Okay, good job. All right, number 11. Number 11. So here's a word problem over systems. It says a woman bought some large frames for $16 each and some small frames for $8 each at a closeout sale. If she bought 26 frames for $280, find how many of each type she bought. All right, so when I talk to my classes about this, I tell them that the system problems really come in 2 forms. System problems that they're either giving you are translations, where it says like 2 times another number more than 3 times x is 15. That's a translation. It's basically mathematical words written out. Or they're giving you standard form, where standard form always have totals. Okay. So in this one, this is a standard form problem. How do I know that? Because it gives me totals. What are my totals? There are 2 of them in here. Whenever you have a total, you're going to be writing standard form.
the number of frames and the price.
You got it. So one of our totals is 26. Another total is the 280. So what we have so far is this. This is all in standard form. Remember, standard form looks like AX plus BY equal to C. C is like our totals, and then we're going to fill in the other information. So let's fill in some things. Now remember, the 26 is about frames. the 280 is about dollars. So keep that in mind. So we've already used the 26. We've already used the 280. We're not going to use those again. Which equation will the $16 for large frames and the $8 for small frames go? Which equation should I put these numbers in? The frames or the money?
The frame,
Say it again.
the frames,
The frames? Again, look at what's on these numbers. What does that symbol mean?
Dollar.
Dollars. Okay. So this is in dollars. This is in dollars. So let's put those with the dollar equation. That's the only thing that makes sense. Okay. So over here, just so you know, we have large frames and we have small frames. What would be a good variable to use for those?
L and S.
You got it. L and S. There's nothing wrong with using X and Y, just as long as you know who is who. So with the dollars, it was $16 for a large frame and $8 for a small frame. Should I add these or subtract these? What should go between there? What sign?
Add.
Add. Okay. So, and notice that this makes sense. This is dollars, 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 money, money, money. That makes sense. Up here, it wouldn't have made sense if I put the 16 and the 8 because it would have been money, money frames. That's weird. That doesn't make any sense. All right, now we've used the 16, we've used the 8, we've used the 26, we've used the 280. All of my numbers have been used. So what's this last equation going to look like? If I've used all my numbers,
L plus S.
L plus S. Okay. So here are our two equations. All we got to do is solve them. Nothing crazy there. So what method would you like to use to solve these?
Substitution.
Substitution. We could absolutely do substitution. Or even easier for this, elimination. Okay. But since you said substitution, let's go with substitution. I'm okay with that. Substitution. So what variable would you want to solve for? In which equation? Do we want to use the top equation? Do we want to use the bottom equation? Which one?
The top equation.
Yeah, let's definitely take that top equation. So which variable would you want to solve for? Would you want to solve for L or for S?
S.
All right, let's solve for S. So L plus S equals 26. So how do I get S by itself?
Subtract L.
All right, minus L minus L. So S is equal to 26 minus L. All right. So all we got to do now is take this and plug it into the second equation. So 16L plus 8 times 26 minus L equals 280. So what are we going to do now?
Distribution.
Yeah. We're going to multiply 8 times 26, and that's going to give us 208. Then we're going to take 8 times negative L. That'll give us negative 8L equal to 280. And then we still have the 16L in front. All right, now what?
Combine like terms.
Boom. So that will give us 8L plus 208 equal to 280. And now?
Divide by
No division yet.
280.
Subtract the 208. Let's get L by itself. So 8L equals 72. And now what?
now it's divide by 8.
Now it's divide by 8. So how many large frames did we buy?
9.
Perfect. How do I figure out my small frames?
Substitution.
Yeah, we're going to plug back in to one of our original equations. Which one's the easiest to plug into, the top or the bottom?
The top.
You got it. So all we're going to do is take 9 plus S equals 26. So subtract 9, subtract 9. How many small frames did we buy?
— 17.
Yay. And there's your answers. 9 large frames, 17 small frames. Okay. Whew. I know you guys are working hard. You're doing great. Keep it up, okay? All right, so number 12, long division. Long division. So we have x squared plus 13x plus 42 divided by x plus 7. So I went ahead and put it in the long division format. Just a couple reminders for you. Remember, with long division, everything under the radical should be in standard form, meaning from the highest power on down. So 2, 1, 0. And you should make sure that every term is there. So if this was 3, 2, 0, see how I skipped over the 1? I said 3, 2, 0. I would have had to put in a 0 term for the 1. So anytime you're missing terms, remember you put in a 0 for it. And always make sure that you're in standard form. From the highest power on down. It should be normal counting. 2, 1, 0. That's normal. I didn't skip anybody. All right. So let's do some long division. So remember, this is the first guy you want to get rid of. Okay? And this is who we're going to use to help us get rid of all of our first terms. So we need to figure out what times my x will give us x squared.
6 times 7.
Whoa. 6 times 7 is not x squared.
Wait. Sorry.
So what times x gives us x squared?
X.
So there's our top piece. And then we're going to take X and we're going to multiply it by the entire front of my division. So what is X times X?
X squared.
And what is X times 7?
7x.
7x.
Okay. And then now all you do is subtract down. What's going to happen to the X squareds?
Cancel.
Which we knew was going to happen. And then I always come over here and subtract down, and I always write this out. So I have a positive 13x, and I'm subtracting a positive 7x. So what is 13x minus 7x?
6x.
And everybody else trickles on down, like Tetris. Da, na, 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 na. And there we go. And now all you do is repeat the process with a new term to get rid of. So we're going to think, what times my x will give us 6x? So what times x?
Basic.
Yeah, a positive 6. And it's going to be important that you put the signs with it. So it's a positive 6. So now we're going to take this 6 and we're going to multiply the front. So what's 6 times x?
6x.
6x, no surprise there. And what's 6 times 7?
42.
No surprise there. And then all we're going to do is subtract down. So what's going to happen to these 6x's?
Cancel.
Just like what we knew was going to happen. And what's going to happen to the 42s?
Also cancel.
Yeah, they're also canceled because it's 42, a positive, minus a positive 42. So this right here is what you call the quotient. This right here is your remainder. Okay. If there usually was a remainder, then remember that the remainder would get added on to the end with the remainder on top, and in the denominator, you would have put the x plus 7. Okay. So remember, remainders get added on to the end. All right, there's number 12. Long division. Although you could have done factoring on that. Which leads us into, I believe, yep, here it is, factoring, and it's a cubic. When you are doing your exam, whether you're in iMathAS or MyMathLab, always make sure that you are aware of their variables. So this factoring has an S as the variable. Do not put X in there. It will count it wrong. You must use S. All right. So how do we factor this cubic? It's a formula. Do you remember what it is?
Sum of two cubes?
This is not a sum.
A difference.
Yes. But I will write the sum of cubes. But this one is the difference of cubes. Because it's subtraction. And remember that it's a formula. And the formula for these look like this. So a cubed plus b cubed is a plus b. Then it's a squared minus ab plus b squared. The difference of cubes is a cubed minus b cubed. which is factors to a minus b. I put a plus again, silly Mr. Armstrong. And it's a squared plus ab plus b squared. There's a minor difference between these two, and it's where these signs go. In the sum of cubes, it's a plus, then the minus. In the difference of cubes, it's a minus, then the plus. So be careful of that. So all we need to do is take the cube root of these. What's the cube root of s cubed?
S.
S. That's your A. And what's the cube root of 125?
R.
5. And that's your B. All we have to do is fill in the equation. So our A is S minus our B is 5. And then it's A squared. So S squared is S squared. Plus, this is A times B. So 5 times S is 5S. And B squared. So 5 squared is 25. And there you go. So you got to know how to factor cubics. Any questions about number 13?
No.
All right, number 14. So here we are adding or subtracting. Here we are adding or subtracting. So we got 1 over x minus 4 minus 19 minus 3x all over x minus 4, x plus 3. Okay. So generally, when you're adding and subtracting rationals, what you need to do is make sure that all denominators are factored. Well, they've already done that for us. So all of my denominators up here are factored. So in order to add and subtract, what do we have to have?
Common denominator.
Common denominators. So we need to find the LCD, the least common denominator. So what is the LCD going to be between these two fractions?
X minus 4.
X
And
minus
X plus 3.
and x plus 3. There you go. Your LCD is x minus 4 and x plus 3. Because if you look right here, if I cover up the x plus 3, that's the first denominator. See, there it is. And then when I uncover that, both of these make up the second denominator. So x minus 4, x plus 3, x minus 4, x plus 3. There's our common denominators. So here's what I currently have. I have x minus 4. Here's what I need. X minus 4, x plus 3. So what is this guy missing? Here's what I have. Here's what I need.
X plus 3.
So this is going to get multiplied top and bottom by x plus 3. So this 1 is going to distribute through. So what's 1 times x?
X.
And what's 1 times 3?
3.
3.
Okay. Now over here, these two already match. So do I have to do anything with this numerator?
No.
Nope. Leave it alone. If the denominators match, don't change it. And so now we can do the adding and subtracting. So what I usually do when there's subtraction is I go ahead and turn this into a plus, and then I change all the signs. So be careful on subtraction. Know that you are subtracting all of this in the numerator. So I turn that into a plus, and a positive 19 becomes a negative 19. The negative 3x becomes a positive 3x. So I let the negative, the minus here, change those signs. And now all you have to do is put like terms together. So what's coming together up here? What do we got?
4x
4x, perfect.
Plus 3.
Not plus 3, because the 3 and the negative 19 will get together.
Oh, okay.
So these two got together, which became 4x. And these two will get together, which become negative
16.
16. And now we're almost done. We need to see if this can factor. Can 4x minus 16 do any factoring?
yes.
Yes. What?
Factor out the 4.
Factor out the 4. Good. Let's see. So that will give us x minus 4. And then in the bottom, we have x minus 4, x plus 3. Is there any canceling?
Yes.
Yes. Who?
The x minus 4.
Yeah, those two go away. So our final answer is 4.
Over x plus 3.
Brava. There you go. All right, number 15. We are halfway through now because there are 30 questions total. So this is a complex fraction. Excuse me.
Lucy.
Thank you. We got x over 16 minus 1 over x. All of that over 1 minus 4 over x. Okay. So there are two ways to go about this. You could add and subtract your rationals together in the top and the bottom, and then do the keep, change, flip because it's division. Or I know the way that all of us were taught was clear the fractions. That's the easiest way to do this. So we want to clear out all these denominators, the 16, the x, and the 4. In order to do that, you need the LCD. What is the LCD going to be between 16x and x?
16.
A little bit more, 16 and
16x.
you got it. So we're going to play Oprah. You get a 16x and you get a 16x and you get a 16x and you get a 16x. Everyone gets a 16x. All right. So remember, we're doing this to clear out the denominators. So what's going to happen between the 16x and the 16?
So 16 cancels out and it becomes x squared.
Yeah, because x times x is x squared. Good. We still got the minus. What's going to happen between the 16x and the x?
The x cancels out and it becomes 16.
Yay. So there's our new numerator. All right, what's going to happen between 16x and 1?
becomes 16x.
Yep, no change. And what's gonna happen between the 16x and the x?
The x cancels out and you multiply the 16 by 4.
Okay, and 16 times 4 is a 64. All right. And then now, just like before, all we need to do is there any reducing here? Or sorry, not reducing, factoring. Do any of these factor?
Yes.
What?
The x squared.
Okay, so the x squared minus 16, what does this become?
4.
A little bit more than that. It's going to be 2 parentheses. Tell me what the 2 parentheses look like. Because this is a difference of squares.
X plus 4 and x minus 4.
Yeah, there you go. There's your numerator. Does the denominator factor any?
Yes.
Yes, what do we do?
We can take out an 8.
A little bit more than an 8, but I like where you're going. You're thinking GCF, but it's bigger than an 8.
The 16.
Pull out 16.
The 16.
Yes. And that will leave us with what?
X minus.
Okay. And then last but not least, is there any canceling? I assume you said the x minus 4. You kind of got cut off.
Cancel x minus 4.
There we go. And so what's our final answer?
X plus 4 over 16.
Yay. Amazing. There it is. Okay. All right. All of our favorite piece right here. Solve the equation. Solve this equation. And that is a z that is down there. So how are we going to solve this rational equation? What are we going to do? Say it again.
Find the LCD.
Yes, we need an LCD again because we want to get rid of the fractions. We hate fractions. So let's just get rid of them. So what's the LCD going to be between Z, 5, and Z?
Five Z.
5Z. So everyone's going to get multiplied by 5Z. You get a 5Z. And you get a 5Z. And you get a 5Z. So what's going to happen between the 5Z and the Z?
The Z cancels out and you multiply 5 by 8.
Yay. And that gives us 40. What's going to happen between the 5Z and the 5?
The 5 cancels out and you multiply by Z.
So that gives us Z equal to, what's going to happen between the 5Z and the Z?
The Z cancel out.
6 times 5.
And that's 30. All right, now solve for Z. What do we get?
Equals -10.
Yay. Now, remember with these, you have to check the answer. And really what you're checking for is to make sure none of the denominators are 0. So here's where we plugged in. Are any of these 0?
No.
Then our answer of -10 is fabulous. All right. There's number 16. Let's jump over to number 17. Okay. 17 says Smith Engineering is in the process of reviewing the salaries of the surveyors. During the review, the company found that an experienced surveyor can survey a road in 3 hours. An apprentice surveyor needs 8 hours to survey the same stretch of road. If the two work together, find out how long it takes them to complete the job. So 8 and 3. So remember that these look like the following form. Usually it's about a person or an item, 1. And then they always want to work together. So that's why there's addition. And this is about person or item 2. And then this is them together. They usually take this form. So in our case, we have an experienced surveyor, and they want to work together with an apprentice surveyor to figure out how much they work together or how long it will take them. All we have to do is put in our numbers and then solve. So it says the experienced surveyor takes 3 hours. The apprentice surveyor takes 8. What number is going to go under the experience?
3.
3. And what number goes under the apprentice?
8.
8. And there we go. Just like what we just did a second ago with number 16. We want to solve for X. Okay. So we need that LCD. What's going to be the LCD between 3, 8, and X?
32x.
32 would work, but we can go even smaller. Just a little bit smaller.
24?
Yeah. 24x is the better number. But don't get me wrong, 32 will work. So play Oprah again. You get 24x, and you get 24x, and you get 24x. So what's going to happen between the 24x and the 3?
X.
You got it. The 3 goes away. The 24 becomes 8. So 8x times 1 is 8x. What's going to happen between the 24x and the 8?
Yeah.
The 8 goes away. The 24 becomes a 3. And that gives us 3x. Equal to, what's going to happen between the 24x and the x?
That's canceled out.
Yeah, and we're left with 24. And now all we got to do is solve. 8 plus 3x. What does that give us?
11x.
And then now what do we do?
Divide by 11.
Divide by 11, divide by 11. Okay. So that's going to tell us that x is equal to 24/11. So because this is a word problem, this is where you need to make sure that you read. This is the one thing that drives me nuts about this word problem. In my math lab, it says it actually wants the fraction. I can't remember what IMathAS wants. It might be the decimal, it might be the fraction. So make sure that you read the fine print to know how they want your answer to be. My math lab wants the fraction, which is really weird because why would I say, oh, when we work together, it will be 24/11 of an hour. That's just weird. No one says that. If I walked up to my boss and say like, boss, I'm going to work 24/11 today, she'd probably slap me. Okay. But that's what it's after. And of course we should check it. I meant to do that. We need to check. And again, all you're making sure is that your denominator is not 0. So if I put 24/11 here, is that 0?
No.
No, that's 24/11. So this answer is fine. So there we go. There's number 17. Has a little form to it. All right, number 18. I believe this one's a little bit of scientific notation. So we're going to take 5 times 10 to the 18th. And we're going to multiply that by 2.4 times 10 to the negative 4. Okay. So the first thing you're going to do is you're going to take your numbers times your numbers. I don't know why I put an X there. So we need to take 5 times the 2.4. And what do we get?
12.
12 times 10. So we take numbers times our numbers. And then we're going to take our powers, our exponents, and we're going to add them. Exponent plus your exponent. So what is 18 plus a negative 4?
14.
Say that again.
14.
14. Okay. Now, before you can finish, you got to make sure that this is still in scientific notation. So are we still in scientific notation with 12 times 10 to the 14th?
No.
No. Because remember, this number right here has to be between 1 and 0. Or sorry, 1 and 10. So what do we got to do? Take our decimal that's right here and move it one place to the left. So our number that we should really be worried about is 1.2 times 10 to the, what happens when we move one place to the left? What does that do to this power? It would what?
Increase.
Increase. And it's going to increase by 1 because we only moved one place. There's our scientific notation number. So the numbers multiply the numbers, the exponents add, and then you got to make sure that it's still in scientific notation. Okay. Number 19.
Well, I'm sorry, I have a question.
Sure. Yeah, let's go back.
Will the recording of the Zoom be posted so we can review it later?
Yes, absolutely. Forever and ever.
Okay.
All right. So what do they want us to do on number 19 here? What do they want us to do?
Add the exponent.
We're going to add the exponents because all they want us to do is distribute. That's it. So you're just adding fractions. No biggie. So we're going to go through and we're going to distribute. So if you just go to your calculator and you take 1/3 plus 2/3, you end up finding that it's y to the, excuse me, first. Because all you had to do is add the exponents. 1/3 plus 2/3 is 1. And then all you're going to do is take and add these two exponents. 1/3 plus 2/5, which that one, I don't know off the top of my head. I mean, I'm sure I could do it real quick, but I'm lazy. So just go to your calculator. 1/3, scroll out to the side, plus alpha y equals 2/5. And there you go. 11/15. And so that's the answer. That's it. That's all they want. Can you distribute through? Any question about number 19? Okay. Number 20. We're getting there. We're about to start some of the quadratic stuff. All right, so it says rationalize the denominator. How do we rationalize this denominator? So we got 4/1 minus the square root of 3.
Multiply by 1 plus the square root of 3.
Yes, multiply by 1 plus the square root of 3. You got to use that conjugate because the conjugate of subtraction is addition. So the cool thing is that down here, we're not going to do a full FOIL. All we have to do is what? How do I multiply these two?
The first and the last.
The first and the last. The Florida. All we got to do is the Florida. Multiply the first, multiply the last. Because the middle will cancel out. That's what's cool about conjugates. You don't have to do the O and the I. All right, so what's 1 times 1?
1.
Okay. What's a negative times a negative? Or a negative times a positive?
A negative.
Negative. And the square root of 3 times the square root of 3 is just 3. So what's 1 minus 3?
4. I mean, 2.
2. Negative 2. So there's our denominator. The numerator, all we have to do is distribute the 4 through. So what's 4 times 1?
4.
And what's 4 times the square root of 3?
4.
4 square roots of 3. Because it doesn't actually go in there and multiply that to become 12. So there's our numerator. Last thing you got to do is simplify. Can 4 be divided by negative 2?
Yes.
So we're going to divide both of these 4s by negative 2. So 4 divided by negative 2 is negative 2. 4 divided by negative 2 is negative 2. And there's your answer. Because both of these can be divided by negative 2. All right, number 21. Last 10 questions. So number 21, we're going to solve. So we got the square root of x plus 6 equal to the square root of 2x minus 1. All right. So we're going to solve this one. Remember, in order to solve radicals, they really do need to be set. You need to get one radical by itself. What's cool is both of these radicals are by themselves. So for this, once you've got the radical by itself, how do I get rid of a square root?
Square both sides.
Yeah. All you got to do is square both sides. So what's the squaring going to do to the square root? Get rid of it. And it's going to get rid of it over here. The square will cancel out the square root. And now all we got to do is solve. So how do I get this? How do we get the x by itself? What are we going to do?
-6.
Okay. So that will give us x equal to 2x, and that will be a -7. Now what?
Divided by 2.
No dividing yet. Got to get your x's all on one side.
Subtract the 2x.
Subtract the 2x. So that'll give us -1x equal to -7. Now what?
Divided by -1.
Now do your division. There you go. So x is equal to 7. Because a -7 divided by -1 is a +7. Now you got to be careful because just like the rationals, you also have to check this. Make sure that it is true. So we actually have to check this all the way through. So we're going to take 7 plus 6, and then we're going to do the square root of 2 times 7 minus 1. So what is 7 plus 6? Say it again.
13.
You got it. So this is the square root of 13. What is 2 times 7?
14.
And 14 minus 1?
13.
So it does check out. So this answer is A-OK. Rationals and radicals, you need to check those answers. All right. Number 22, another word problem. So it says the formula V equal to the square root of 2gh gives the velocity v in feet per second of an object after it falls h feet accelerated by gravity g in feet per second squared. If g is approximately 32 feet per second squared, find how far an object has fallen if the velocity is 48 feet per second. All right, so we know some things. Just writing some stuff down. So here's what we know. We've got this equation, and this is what they're after. So what are we going to do with these numbers 32 and 48?
You put them in.
Yeah, plug them in and then solve for the missing variable. So 48 is V equal to the square root of 2 times our G is 32, and then our H. All right, so let's solve. How do I get rid of, well, let's do this real quick. What's 2 times 32?
64.
All right. Is my radical by itself?
Yes.
Yes. So how do I get rid of the square root?
Square both sides.
Boom goes the dynamite. So I will tell you that 48 squared is 2,304 equal to 64H. Now what do we do?
Divide by 64.
Yes, indeed. So H is equal to what?
Six.
36. Good. But we're not done yet because this also wants to know what's the label. So up here, it says an object after it falls H feet. What's the label?
Square feet?
No. Square feet is for gravity.
Oh.
We found H.
Feet.
It's just feet. That's it. Because it says right here, an object after it falls H feet. 36 feet. And there you go. So the answer is 36 in the first blank, feet in the second. All right. Now we are on to nothing but quadratics. Nothing but the quadratics. So 23. We've got x squared minus 5x minus 24 equal to 0. Now you learned a couple different ways to solve quadratics. Okay. You learned that you could factor. You learned that you could do the quadratic formula. You learned that you could use square roots, but remember square roots is kind of case specific. You also learned that graphing can help you solve too, but it's not the best. So how do we want to approach this problem with solving this quadratic? We can't use square roots on this because I have an extra x here. The only time you can use square roots is just if you have a square. So that really kind of leaves us with graphing, factoring, or the quadratic formula.
Factoring.
Factoring, okay. So then the question is, how does this factor?
X minus 8 and x plus 3.
You got it. X minus 8 and x plus 3. So now that this is factored, how do I continue to solve? What are we going to do now? What are we going to do with these parentheses?
Set each of them equal to 0.
You got it. X minus 8 is going to get set equal to 0. X plus 3 is going to get set equal to 0. So what does x equal for my answers?
X equals +8 and
That's right.
-3.
Because you add 8 to both sides. And a -3 because you subtract 3 to both sides. And there we go. There's number 23. A quick factoring to solve. Number 24. So number 24, it tells you exactly what to do. Use the square root property. And I would do that. All right. So we got 2x minus 1, that is squared, equal to 25. All right. So how do we solve this? What are we going to do?
Square root both sides.
You got it. Because how do I get rid of something squared? We square root it. And you can only square root both sides once the square part is by itself. So because this square is by itself, that's why we can square root both sides. All right. So what's going to happen between the square root and the square? What do we get? What's going to happen between these two?
It becomes 2x minus 1.
Yeah. And what do we get on the other side?
5.
No, it's a little bit more than that. It's not just 5.
Plus or minus 5.
Yes, plus or minus 5. When you guys get in that college algebra, this is going to be very important. When you square root both sides, you put plus or minus in front of that answer. All right, now let's continue to solve. We got to get x by itself. So what are we going to do now?
Add 1.
Plus 1, plus 1. Now remember, you can't put these two together yet. So this is going to stay as 1 plus or minus 5. Can't put those together yet because what you really got going on here, it's like you have two equations. You have 2x minus 1 that equals a positive 5. Or you have 2x minus 1 that equals a negative 5. So you could separate it out if you really wanted to and solve two separate equations, but I like to solve it together. All right, so now how do I get x by itself? What are we going to do?
Divide by 2.
Divide by 2. So we're going to have two answers. One where it is 1 plus 5 divided by 2. One where it is 1 minus 5 divided by 2. So what is 1 plus 5?
6 over 2.
And 6 divided by 2 is?
3.
There's one of our answers. What is 1 minus 5?
-4.
Divided by 2, which is?
-2.
Ta-da. Guys got this. You're doing great. All right, number 25. It says use the quadratic formula. So weird. The first one was factoring. The second one was the square root method. The third one is the quadratic formula. 10m squared minus 2m equals 3. All right, in order to use the quadratic formula, what has to happen first?
Find the discriminant.
We will, but in order to, before we can do any of the formula, what do we have to make sure about this?
Set the equation equal to 0.
Yeah. I didn't say this before, but on number 23, before you can do any factoring, you must be set equal to 0. That's good. And the same thing has to happen with the quadratic formula. You must be equal to 0. So we have to subtract 3 from both sides, which gives us 10m squared minus 2m minus 3 equal to 0. And now we can start doing the quadratic formula because we now know the a, the b, and the c. What is our a? What is our A value?
Oh, 10,
10. What's our B value?
-2,
And what's our C value?
-3.
Okay, so I find the discriminant first, which is the part under the radical, the B squared minus 4AC, because I find that if something goes wrong, it generally happens here. So I find the discriminant first. So we're going to plug in. So our B is -2 minus our 4 times our A, which is 10, times our C, which is -3. All right. So the first thing I deal with is the squaring. So -2 squared is 4. The second piece I deal with is the multiplying of these three numbers. I don't touch the minus here. I leave that alone. So this is 4 times 10 times -3. So that should be -120. Just double checking. Yeah. And then last but not least, I bring down the minus and do the subtraction, which ends up being 124. The other reason I like to do the discriminant first, because like, I've already kind of talked about college algebra a little bit. When you go to college algebra, if this number is negative, you stop. You don't move on with the rest of the quadratic formula because we only care about real solutions in college algebra. But because we're in intermediate algebra, no matter what this number was, we'd always continue on. So we have 124. So now with number 25, this is where I will do the rest of the equation, which m equals, because that's our variable. If it was x, I would have put x there. The opposite of b plus or minus. Here's the full quadratic formula, b squared minus 4ac all over 2a. So I fill in. So the opposite of b, so the opposite of a -2 is a +2, plus or minus square root of, we already know what this number is. It's right there. It's 24 or 124. And then this is all over 2 times our a, which is 10. Much easier to deal with this than worrying about every single number that we had. So simplifying some stuff down, 2 times 10 is 20. So we got 2 plus or minus square root of 124 all over 20. All right. So now we have a little bit of cleanup. First thing, we need to break down the radical of 124. So we need this to reduce. So what is going to be the biggest perfect square that divides it?
4,
4. And the other one is the square root of 31. What's the square root of 4?
2,
Square roots of 31. So this number is going to come right in here and replace that. So what we have is 2 plus or minus 2 square roots of 31 all over 20. And then last but not least, you're going to look at all of your numbers out here, 2, 2, and 20. Is there a number that divides all three of these?
yes,
What number?
2,
2. So in the end, 2 divided by 2 is 1, plus or minus 2 divided by 2 is 1. square root of 31. 20 divided by 2 is 10. That is our answer. 1 plus or minus 1 square roots of 31 all over 10. Now you can separate them out into 1 plus 1 square roots of 31 all over 10. And then your other answer would be 1 minus 1 square roots of 31 all over 10. So you can separate them out if you want to. Number 26. Almost done. Last 5 problems. So number 26, it says a waterfall has a height of 1,900 feet. A pebble is thrown upward from the top of the falls with an initial velocity of 24 feet per second. The height of the pebble h in feet after t seconds is given by the equation h equals negative 16t squared plus 24t plus 1,900. It says, how long after the pebble was thrown will it hit the ground? Okay. So the cool thing is this equation right here already has all the above information put into it. We just want to figure out how long after the pebble was thrown will it hit the ground? Okay. Now, we have 2 variables. Which variable are we looking for? The height or the time?
The height?
We are not looking for the height. If you go back and read the question, it says how long after the pebble was thrown. How long? That means time.
Okay.
Okay. So we're looking for the time. That we don't know. But we do know the height. The height is when it hits the ground. How high off the ground are you if you're on the ground?
0.
0. When you're on the ground, that means your h is 0. So this is what we're looking at. How are we going to solve this? How can we solve this?
Factoring.
You can try factoring. That's a lot to factor. Those are some pretty big numbers. What else could we use? And I don't know if it does factor or not.
The quadratic formula.
Absolutely. I would use the quadratic formula. And because this is a word problem, and when you look right here, it says we can round, I'm going to let the calculator do all the dirty work for me. All I got to do is just make sure I fill in correctly. So because we're equal to 0, we already know what A, B, and C are. What's our A?
Negative 16.
Negative 16. Okay, negative 16. What's our B?
24?
What's our C?
1,900.
Okay. So unlike before, like what we did up on number 25, how I kind of broke it down because they wanted an exact answer, because I can round on this, I'm just going to plug straight into my formula. So the opposite of B, which is a negative 24, plus or minus the square root of B squared. So that's 24 squared. Minus 4 times our A, which is negative 16. Our C, which is 1,900. all of this over 2 times our A, which is negative 16. I'm going to go straight and put this entire piece here in my calculator, and it will look just like this. So I'm going to go to my calculator. I'm going to hit alpha y equals negative 24. I'm going to do a plus first because I can't put plus or minus in here. It will confuse the calculator. Hit my square root key. Then it's parenthesis 24. Close it. And it's squared. Minus 4 parenthesis our A, which is negative 16. Close it. Our C, which is 1,900. All of this over 2 times our A, which is negative 16. And I put 22, and I need to fix that. So right here, that's the same way it was written on my piece of paper. Same exact way. Oops. All I got to do is hit enter. Here's one of our answers. Negative 10 point, and it says to round to the nearest tenth. So what would the nearest tenth be?
7.
2,
So negative 10 point what?
2,
2. Nearest tenth would be 1 decimal place. Okay. And then now we'll get the other answer. I'm going to scroll up, grab what I just did, and all I got to do is change the plus to a minus. I just got to scroll back through. Almost there. Change that to a minus. There's the other answer. So rounded to the nearest tenth, what do we get?
11.7.
All right. So one of these is the correct answer. One of them is a weird answer. Which one is the correct? The negative 10.2 or the 11.7?
11.7.
The 11.7. Because remember, this is all about time. You can't have negative time. If you have negative time, that means you have invented a time machine and you went back in time. Please let me know. I will be a partner with you and we will be madly rich. Okay. But this answer right here is junk. You got to throw it out. Because that means you're going back in time. This is the only answer that makes sense. And then this question also wants to know, what's the label? Is it feet per second, seconds, or feet?
Seconds.
Seconds, because it's all about time. There you go. All right. Number 27. Again, this is where my math lab and iMath.AS differ. Because I don't believe you do any graphing with the iMath.AS for number 27. So we've got this equation, f of x equals parenthesis x minus 2 squared plus 5. And they want us to graph, and they want us to find the vertex and the axis of symmetry. Well, this equation is already in what we call vertex form. Vertex form looks like this. F of x equals a, x minus h squared plus k. Where in order to find the vertex, you need to know what h and k are. And so when I talk about this, I tell you to think about the opposite of what you see, and the k is you're going to keep. So if we look up here, if I want to know the vertex of this, Well, there is an A in front. What number is right here?
1.
There's a 1 there. So that's our A. This is our H. This is our K. So what's the vertex going to be? Remember, think the opposite of what you see up here. That's what's going to go in here. So what's the opposite of -2?
2.
So there's the H. And then what's our K?
5.
5. There's our vertex, 2, 5. Okay. Now, it also wants the axis of symmetry. I call that the AOS. The AOS is an equation. Good, and it does want you to type in an equation. And it's really easy to find that equation because all the equation is for the AOS is the X value from the vertex. So our AOS is X equals, what was the X value? What was the H?
2.
There you go. There's the vertex. There's the axis of symmetry. Now, to graph, let's talk about graphing real quick. Graphing is not too terribly hard. 3, 4, 5, 6, 5, 6, 10, 2, 3. Okay. When you graph, so when you click on your graph here in iMathAS, and the same thing in my math lab, you get a set of tools that pop up down below. Okay. So you get a set of tools that pop up down here. So once you click on your graph, you get tools that pop up. One of your tools is like an arrow, which is your selector tool. You get another tool that's like a line with 2 dots. Then you get your quadratic tool, which has 2 dots. And then there are a bunch of other tools. Okay. Because we are graphing quadratics, you're going to select this tool. And the first thing that you're going to graph is the vertex. So you'll select this, you'll select the quadratic, and then you'll come up to your graph, and you're going to graph 2, 5. So 2 and 1, 2, 3, 4, 5. Once you select that, then when you start to move your mouse around, you'll start to see U's or arches. So we need to select one more point to make it actually be done. Here's how you're going to get that second point for this. So the first point you plot is the vertex. That's first. And then the second point you plot will solidify it. Here's how you're going to do that. Go to your calculator. Go into the y equals, and we'll let the calculator graph this. So we've got 1 parenthesis x minus 2, close the parenthesis, and it's squared, and then plus 5. So this was our equation. You don't have to have the 1 if you don't want to. If you hit graph, see there is the 2, 5. Now we just need another point. Well, where can I go on my graphing calculator to look at all the points? Where can I go to see a list of all the points for my graph?
Table.
The table. So just hit second graph. Here's our vertex, 2, 5. And look at all these other points that you could use. We could use 0, 9, or 1, 6, or 3, 6, or 4, 9. Just pick one of them. It doesn't matter which one you pick. We just need another point. So let's grab 0, 9. Okay, so I come back. So like I said, I selected the quadratic. I graphed my first one, and then the second point we're going to plot is 0, 9. 3, 4, 5, 6, 7, 8, 9. And once I select this point, then my graph will come in. And I'm going to put a couple other points in here just to help me out. So it roughly looks like this. Close enough. And there you go. So let your calculator help you out. Let your calculator help you out. So again, the moment you click on the graph, you'll select your tools, select the quadratic, plot the vertex first, and then you'll plot the second point, which was 0, 9 that I chose, and then it will solidify the graph. And you're done. Okay. So there's number 27. Number 28 wants us to find the vertex. So you can do one of two things. We can go into our calculator to find the vertex. And we can put our equation in. So 3x squared plus 6x plus 4. Hit graph. And there's our vertex. You can see it plain and simple. It looks like it is 1, comma, or sorry, negative 1, comma 2. Sorry, negative 1, comma 1. And we could double check that. There's a feature on here that if you hit second trace, this is a minimum because it's a U shape. And if we scroll to the left, hit enter, got to be to the left of your vertex. Then it says scroll to the right, hit enter, and then now take a guess. I believe the vertex is there. And we are right. This is negative 1, comma 1. So there's the vertex. Or you can use a formula. And the formula looks like this. You find step 1, find the AOS, which looks like this. X equals the opposite of B over 2A. So if we look at our equation up here, what is the A value?
3,
3. What is the B value?
6,
What is the C value?
4.
4. So all we got to do is just plug in really the A and the B. We really didn't need C. So it says the opposite of B. So that's a negative 6 all over 2 times our A, which is 3. So that gives us negative 6 over 6, which is negative 1. Oh, look, there's our X value, negative 1. Then after that, find the Y value by plugging in the X value. So all we got to do is take negative 1 and put it in for X, and that will tell us the Y value. So negative 1 squared is 1. And that gives us 3 minus 6 plus 4, which in the end ends up being the positive 1. So 2 ways. You can use your calculator or you can run some quick formulas. Almost done. 2 more. 2 more. Number 29, I believe, is a word problem. And then number 30 is a complex number problem. Yep, word problem. So here it says, if a projectile is fired straight up from the ground with an initial speed of 160 feet per second, then its height h in feet after t seconds is given by the function h of t equals negative 16 t squared plus 160 t. Find the maximum height of the projectile. All right, right here, this is the key word. When you see the word maximum, what does that mean you're after?
Vertex.
You're after the vertex. Okay, and because we're looking for the height, that means we're looking for the y value because that's where the h is. T is like the x value. Okay, so we're after the height. Since we're talking about height, which one of these labels is going to be our answer? I don't even need the number to know which one it is. Is it seconds, feet per second, or feet?
Feet.
We're after feet. There you go. All right. So let's jump into this problem real quick. This is why I showed you the formulas a second ago. All we need to do is find the vertex, and we're going to take the y value. Because the x value is t, the y value is our h. So what's our a?
Negative 16.
What's our b?
160.
And our c, even though we don't need it, but it's good to practice, what is our c?
0.
It is 0. Whenever you're missing one of these numbers that's up here, it's 0. So if I'm missing the squared part, it would be 0. If I'm missing the t part, the b would have been 0. Because I'm missing c, it's 0. All right, so let's plug in. So the first thing we're going to do is find that AOS. So in our case, our x value is t this time, which is still the opposite of b over 2a. So what's the opposite of our b?
Negative 160.
All over 2 times, what's our a value?
Negative 16.
Okay. So that gives us negative 160 all over a negative 32. And what do we get for t? What is negative 160 divided by negative 32?
Positive 5.
You got it. So it takes 5 seconds to reach the maximum. But that's not what we're after. We're after the h. So in order to get the h, plug back in. Negative 16, 5 squared, plus 160 times 5. So that's negative 16 times 25 plus 160 times 5. So negative 16 times 25 is negative 400 plus 160 times 5 is 800. So what is H?
400.
You got it. 400 feet. That is the maximum height the pebble will reach. We did it. We made it to the last problem, number 30. It is a complex number problem. So we got this 9 plus 7i all over 1 plus I. And in the end, they want it in standard form. Okay? Which means that we want it a plus bi. We want the real part and then the imaginary. All right, easy peasy. How do we take care of this? Remember, I is just a fancy way of saying square root of a -1, which means that we have a square root in the denominator, and we don't like that. What do?
Multiply it by the conjugate.
Yes, in this case, it's actually called the complex conjugate. So 1 minus I. So in the denominator, we don't have to do full FOIL, but in the numerator, we will. So in the denominator, we Florida. What's 1 times 1? And then we'll take the i's and multiply them. What's a positive times a negative?
Negative.
And what is I times I?
I squared.
All right, and what do we know about I squared? What does it equal?
-1.
Yay. So we know that this I squared is really going to turn into 1 minus a -1, which in the end gives us what for the denominator?
2.
2. All right, now let's work on the numerator. So we're going to FOIL. What's 9 times 1?
9.
What's 9 times -I?
-9i.
Yep. What is 7i times 1?
7i.
And last but not least, what is 7i times -I?
-7i squared.
Yay. And then again, we already know that I squareds is really just a -1 in disguise. So -7 times a -1 is a positive 7. So what does our numerator really look like on top now? Who's getting together?
The i's.
The i's. So what is -I and a positive 7i?
-2i.
Okay. And then who else gets together?
The 9 and the 7.
Yay. And what is 9 plus 7?
16.
Last but not least, all we got to do is break this apart into its fractions. 16 over 2 minus 2i over 2. And do any reducing now. What is 16 divided by 2?
8.
And 2 divided by 2.
1.
That's what they're looking for. 8 minus 1i. And that, my friends, is your intermediate algebra final exam. We did it. We made it.